In this video, we'll be looking at rational functions. So, what is a rational function? A rational function is basically a function which is a ratio of two polynomials, and the denominator cannot be 0. So let's just look at an example of a polynomial. Let's look at x over x squared plus 9. Okay. The way to find y asymptotes, actually, I should clarify, an asymptote is a line where a curve approaches but never reaches. So anyway, to find y asymptotes, you just let x equal a power, you let x approach infinity. So in this case, letting x approach infinity will mean that there's a y asymptote at y equals 0. To find x asymptotes, you usually find factors of the denominator. There are none in this one, but you can find x values from there. So for example, if x minus a was in the denominator, then there'll be an asymptote in x equals a. Okay, alright. So just like any algebraic manipulation or anything like that, you can find intersection points. So if x equals 3 and y equals x, y to be equal to 3, actually, another thing you can do with rational functions is find intersection points of the curve and perhaps a line or something. So let's say that y you can find with a normal line, so y equals a 12th, and then the function itself, let's use x over x squared plus 9 again. Just say these are equal to each other, so a 12th equals x over, okay, and then you just do some algebraic manipulation here. So x squared plus 9 equals 12x. So let's see if there's factors here. Can't seem to find any factors, so let's try and complete the square. Don't know if my brain doesn't seem to be working here or something. Okay, it's minus 27. Okay, alright. It wasn't an easy one. So x equals 6 plus or minus 3 root 3. So that's the root, well, they're the intersection points. That's where x equals in order for y to equal 1/12. Another thing you can do with rational functions is find stationary points. So let's take just a great function, x over x squared plus 9, and what you want to do is, like last time, like with intersections in general, say y equals k for the point where you want a stationary point, or like the height where the stationary point is. So what you want to do is set them equal to each other. So it's kx squared plus 9k equals x. I've already multiplied it out. So kx squared minus x plus 9k equals 0. Now you're probably wondering what is going on here, why has this happened? But we can use the age-old trick of actually using the discriminant of a quadratic here. So, as a stationary point is tangential to a line, b squared minus 4ac equals 0. Okay, so minus 1 squared minus 4 times by k times by 9k equals 0. Alright, so 1 equals 36k, and k equals a 36th. So input this back into this equation. So 1/36 x squared minus x plus 9 times by 1/36 equals 0. Multiply by 36, x squared minus 36x plus 9 equals 0. That is, I'm just going to complete the square, don't know. Okay, that's 324. Let me just check that, I'm pretty sure it is. Yeah, it is. So x minus 18 squared equals minus 315. Okay, that's not right. Alright, which equals 0. So x equals plus or minus through 35. Yeah, so that's an interesting result. That's they're the x values for the stationary points on this graph.